Now we're into these high density cooling requirements where we're working with rooms that are expecting to have 100 watts a square foot up to, they're talking in terms of 300 watts a square foot on projects that we're seeing today. APC has been very innovative in the new products that they're rolling out to not only provide the cooling for these type of centers, but be able to extract the heat from these hot spots that we're dealing with.
Before we demonstrate how APC addresses your cooling challenges, let's look first at how heat is generated in an IT environment. Here are the heat and airflow paths at chip, server, rack, and room level. Microprocessors and other electronic equipment with heat sinks are designed to dissipate the heat generated at a specific point. This heat is removed from the chassis of servers and other equipment using airflow through the equipment. In most cases, the airflow is from front to back. This airflow can be hindered when the equipment is placed into rack enclosures. The front doors of the racks and power and network cabling at the rear of the enclosure can impede proper airflow. At the room level, airflow is further complicated by multiple zones of different density racks that may exist in a variety of layouts, as well as ineffective cold air distribution and warm air return. This leads us to the top 4 challenges of heat in the data center. 1. Low airflow areas. 2. Hot air recirculation. 3. Room cooling and heat removal. And 4. High density areas. Challenge 1. Low airflow areas. Causes of low airflow areas include the poor placement of crack units on the floor, underfloor obstructions, and gaps or voids in the raised floor. When enclosures do not receive an adequate amount of airflow from the perforated floor tiles, the air must come from another source. The result is the recirculation of hot air from the rear of the rack to the inlet of the enclosure. The solution? APC's Rack Air Distribution Unit, or ADU. To assist in the distribution of cold air from the floor, the ADU pulls cold supply air from the raised floor into the enclosure and distributes it to the front of the IT equipment. By distributing the air directly to the equipment inlet, the ADU prevents supply air from mixing with the room air, ensuring that the air of a proper temperature is supplied to the equipment. The wall of air that is supplied equalizes the top to bottom supply air temperatures. The ADU can provide enough air to cool 3.5 kilowatts per enclosure in a raised floor environment. In areas with enclosures above 3.5 kilowatts and up to 7 kilowatts, the APC Rack Air Removal Unit, or ARU, can also be used to remove hot exhaust air from the enclosure and away from the inlet. Challenge number 2. Hot air recirculation. Power and data cabling at the back of a rack enclosure can block the exhaust air of rack-mounted equipment. When the IT equipment cannot draw the necessary airflow to remove the heat, the airflow through the server is slowed or stopped, creating higher temperatures throughout the equipment. The solution? APC's Rack Air Removal Unit, or ARU. The Rack Air Removal Unit, or ARU, is ideal for medium to high density racks. Taking up 0 U of rack space, the ARU ensures the proper removal of exhaust air and eliminates hotspots. Applications that utilize a drop ceiling or ductwork for hot air return to the cooling system can be optimized with the ARU by installing an optional ducting kit. Challenge number 3. Room cooling and heat removal. Ensuring proper heat removal and humidity control for the room is essential to the overall data center environment. The room-level airflow dynamic is complex and demands a precision cooling system specifically designed to maintain optimal room-level conditions. The solution? The APC Network Air FM. The APC Network Air FM precision cooling system combines a high reliability design with best-of-breed components for maximum availability and performance. The Network Air FM also offers front access for ease of service.
Now we have the smallest footprint in the industry. It's all front access, so you can put equipment right up to the side of our systems and make use of the space that was once reserved in the past for service space is now usable space to the IT department.
The Network Air FM utilizes tandem scroll compressors for capacity control, matching the cooling capacity to the heat load in the room for optimal efficiency.
The biggest weakness in traditional data floor cooling equipment is belt-driven fans, constant speed belt-driven fans. One of the big advantages to not only direct drive technology, but also variable speed direct drive technology is that you can change how much air is delivered to the floor.
Designed with integral direct drive blower and motor assemblies, the Network Air FM eliminates the need for belts, pulleys, long drive shafts, and separate motors that are common single points of failure in other systems.
The fact that we've got the ability to have the front access and have the need for no belt replacement and pulley adjustments and all the things that we've had in the past are gone. Also the ability to have the units talk to each other so that one's not going into cooling mode while the other's going into heating mode. So we have abilities with this new FM system that none of us have enjoyed in the past. So this is a great new product, and it brings a lot of features and benefits to the client.
To ensure optimal cooling within your specific environment, the Network Air FM can be configured for different discharge air patterns. Small computer rooms without a raised floor are suited for upflow discharge air patterns. This configuration draws air from the room into the front or rear of the Network Air FM system, where it is then cooled and discharged into a duct on top of the unit containing grills for distribution into the room. For raised floor applications, a downflow discharge air pattern is available. In this configuration, air is drawn into the system from the top, where it is then cooled and discharged into the raised floor for distribution using vented floor tiles in front of the enclosures. The Network Air IR features all the benefits of the Network Air FM, but is designed for in-row configurations. To utilize a hot aisle, cold aisle design for the most effectiveness with or without a raised floor, a horizontal airflow pattern can be created using the Network Air IR system. The Network Air IR is placed directly in the row of enclosures. This configuration pulls air from the hot aisle into the rear of the unit, where it is cooled and discharged into the cold aisle at near room temperatures. Challenge 4. High-density areas. The high cost of floor space and new, smaller, more powerful IT devices have led to higher power and heat densities in the data center. While the average kilowatt per rack remains in the 1 to 2 kilowatt range, high-density enclosures are becoming increasingly common and increasingly more difficult to cool. Two possible solutions: the Infrastructure Hot Aisle Containment System and the Net Shelter HD. The patent-pending Infrastructure Hot Aisle Containment System is designed for extreme cooling loads of up to 20 kilowatts in a single rack. Using a hot aisle enclosure kit containing end doors and ceiling tiles, the hot aisle is sealed off from the rest of the room. A Network Air IR is installed for horizontal airflow. This configuration ensures that the hot air will not mix with the room. Overcooling the room is a common way to deal with hotspots caused by high-density rack clusters. Not only does this lead to excess moisture removal and increased energy consumption, it does not adequately address the problem. By isolating high-density enclosures in the data center using the hot aisle containment system, the room can be environmentally controlled separately without overcooling. This decreases the amount of energy the system uses and allows the cooling system to be run at its full capacity. The hot aisle containment system is also designed for non-high-density areas, such as converted spaces that are not adequate for data center installations. In a matter of hours, a complete network-critical physical infrastructure can be assembled almost anywhere. In some data centers, the high-density enclosures are placed sporadically rather than in clusters. There are also instances where IT equipment is installed in areas that are not environmentally controlled, such as manufacturing spaces and wiring closets. The solution? The NetShelter HD. Using an integrated patent-pending cooling coil, the NetShelter HD delivers a cooling load of 15 kilowatts within a single rack. Designed for high availability, the fans are N+1 redundant. To protect the IT equipment from dust and moisture, the NetShelter HD enclosure is completely sealed to isolate the equipment from the rest of the room. The NetShelter HD cooling coil is mounted vertically within the rack. This enables an even flow of cool air in a horizontal plane to the front of each server. A common practice for high-density racks is to leave the top half of the rack empty to avoid overheating. Because the NetShelter HD allows 100% of the rack U space to be used without overheating, it allows you to maximize expensive floor space. Heat in the data center is an extremely destructive force, one to be addressed at all levels, the rack, row, and room. Yet, regardless of your specific cooling challenges for today's highly dynamic environments, you can rely on just one solution from just one proven vendor. APC.
There is no other competitor that I've seen that manufactures in this country that is willing to go to the development depths that APC has to develop a product. APC's entree into the market will change the reliability and the dependability of computer floor cooling units. It will change the market perception. It will change the market expectations.